Hello, this is Armando Sosa and my partners Nancy Diaz and Carlos Espinosa. We will present to you our egg bungee jump project. The objective of this project is to predict how many rubber bands do we need in order to drop the egg at 1 meter to make the rubber band stretch as much as it can without the egg touching the floor. And also finding the forces acting on the egg, such as spring constant. Using conservation of energy, we will find kinetic energy, gravitational potential energy, and elastic energy, as well as the velocity of the egg. Materials. For the materials, we will need an egg, rubber bands, a meter stick, tape, and a plastic bag. Step 1. You're going to place the egg inside the bag and seal it with tape and a rubber band. After that, you're going to add another rubber band that we will need in order to let the egg fall. Step 2. You're going to set the ruler away from the floor, set the egg, and let it fall. You're going to let the egg fall with one rubber band attached to it. Then you're going to let it fall a total of 3 times and record the data and find the average distance of it.
The gravitational potential energy of a falling object is defined by mgy, where y is the vertical height. At one point where x is equal to 0, the egg has gravitational potential energy. Once it is falling, it is losing gravitational potential energy and starts getting kinetic energy as well as elastic potential energy. At what point of the falling, it will lose gravitational potential energy as well as kinetic energy, and it will be gaining elastic potential energy. At the bottom of the fall, the energy will be just elastic potential energy. Here we show a graph for better understanding.
The elastic potential energy. The elastic potential energy of a rubber band is 1/2 kx squared, where x is the amount of rubber bands that they are going to be stretched. At x equals 0, the rubber bands are not stretched, so the elastic potential energy of the rubber band is 0. At the bottom of the fall, the rubber bands are stretched by the amount of h minus L, where L is the length of the unstretched rubber band. The egg rubber band will not stretch until the egg passes through the L point. The elastic potential energy of the egg can be defined by 1/2 kh minus L. Kinetic energy. The kinetic energy of a moving falling object is 1/2 mass times velocity squared, where v is the velocity of the egg at the initial position. So in this position, the egg is at rest, so this means the initial kinetic energy of the egg is 0. Also at the bottom of its fall, the egg stops for a moment, so the final kinetic energy of the egg is also 0.
Prediction. For our prediction, we were required to think about how many rubber bands do we need in order to make the egg travel 2 meters without touching the floor. We had one chance only. And we decide that 10 rubber bands will be good. Let's see what happens. Yes, we choose the correct number of rubber bands. Conclusion. In this experiment, we can conclude that the elastic potential energy of the object is dependent on the rubber bands. The more rubber bands it has, the more distance it will travel. Also that the egg acceleration is 9.8 meters over second square, the value for gravity acceleration.